Arctic ice. For years, a sleeping giant is stirring beneath the Arctic ice. For years, the West believed Russia's naval power was fading into history, its mighty warships rusting away, while NATO tightened its grip on the frozen North. But Moscow may be about to shatter that narrative. After decades of silence, one of the most feared warships ever built is preparing to sail again. The colossal Admiral Nakhimov, an immense nuclear-powered battlecruiser once regarded as a symbol of Soviet sea power, has emerged from a massive modernization program armed for a new era of confrontation. Its return comes as the Arctic transforms into a strategic battlefield, with Russia and NATO locked in an intensifying struggle for dominance over vital sea routes, resources, and military access. The 28,000-ton Admiral Nakhimov is the world's largest nuclear-powered surface warship. The mammoth warship has now entered the final phase of sea trials, following one of the most ambitious naval modernization programs in modern history. For the first time in 28 years, the vessel sailed under its own power, signaling the end of a massive refit that transformed the Soviet-era giant into one of the most heavily armed surface combatants on Earth. The vessel belongs to Russia's legendary Kirov-class battlecruisers, floating fortresses originally designed during the Cold War to project Soviet power across the world's oceans. Powered by twin nuclear reactors, the warship can remain at sea for months, operating across vast stretches of the Arctic without the need for refueling. The extensive modernization has equipped Admiral Nakhimov with a new generation of sensors, radars, command systems, and missile weapons. The result is a warship built not only to fight, but to command an entire battle space. Designed from the outset for operations in extreme cold, the ship features extensive winterization systems, heated equipment, and protected working areas capable of enduring some of the harshest conditions on the planet. Its nuclear propulsion gives it the endurance needed to patrol the Arctic for extended periods, where distances are vast and logistical support is limited. The Arctic is no ordinary theater. It is home to some of Russia's most critical military assets, including ballistic missile submarines that form a key pillar of the country's nuclear deterrent. Protecting those forces is expected to be one of Admiral Nakhimov's primary missions, and the ship's air defense capabilities are formidable. Reports indicate the cruiser now carries 96 long-range surface-to-air missiles derived from the S-400 air defense system, enough to create a massive protective shield against aircraft, drones, and incoming missiles. The upgraded battlecruiser is expected to operate alongside submarines, satellites, maritime patrol assets, and MiG-31BM interceptors, helping Russia build a real-time picture of the Arctic battlespace. From tracking submarines beneath the ice to monitoring aircraft thousands of miles away, the battlecruiser is expected to become one of the most powerful command and control platforms ever deployed in the Arctic. The return of Admiral Nakhimov signals Russia's determination to dominate the high north, and the Arctic balance of power may never be quite the same again.
A Russian nuclear-powered attack submarine has surfaced at the center of a growing military spotlight after launching a cruise missile near NATO territory, reigniting concerns over a warship many analysts consider one of the most dangerous underwater predators ever built and a direct challenge to Western naval dominance. Fresh attention is now focused on Russia's Yasin M-class submarine Arkhangelsk after Russian state sources confirmed that the vessel launched a P-800 anti-ship cruise missile in the Barents Sea near NATO's northern frontier. Beyond the missile launch itself, military experts are increasingly examining the extraordinary capabilities of a submarine class that combines extreme stealth, devastating firepower, advanced sensors, and hypersonic strike potential into a single platform designed to hunt some of the world's most powerful naval forces. The latest concerns emerged after confirmation on June 3 that the Russian Navy's Yasin-M-class nuclear-powered attack submarine Archangelsk conducted a P-800 anti-ship cruise missile in waters near NATO territory in the strategically vital Barents Sea. While missile launches by major naval powers are not unusual, this particular event has renewed scrutiny of a submarine class widely regarded as one of Russia's most advanced and capable underwater weapon systems. The Yasin class has dramatically altered the balance of naval power since entering service, with Russian designers prioritizing stealth, survivability, long-range strike capability, and multi-mission flexibility in a way rarely seen in previous submarine programs. At approximately 14,000 tons, the Yasin-M is the largest attack submarine in the world, allowing it to carry exceptionally powerful weapon systems and advanced sensor suites while maintaining remarkable operational flexibility. One of the submarine's most significant advantages is its stealth. Russian engineers incorporated raft-mounted machinery, advanced propulsor designs, specialized acoustic coatings, and extensive noise reduction technologies aimed at making the submarine exceptionally difficult to detect. These measures have led many analysts to conclude that the Yasin class ranks among the quietest submarines ever produced, making it a formidable challenge for NATO anti-submarine warfare forces operating in the North Atlantic and Arctic regions. The submarine's acoustic signature is considered so low that some Western observers have described it as the first Russian submarine designed from the ground up with stealth as its primary engineering objective. Unlike many Soviet-era designs that prioritized speed, deep diving capability, and ruggedness, the Yasin program focused heavily on avoiding detection altogether. This shift in philosophy reflects a broader understanding that in modern submarine warfare, the vessel that detects its adversary first often gains a decisive advantage long before weapons are fired. Supporting this stealth-centric approach is one of the most sophisticated sonar systems ever installed aboard a Russian submarine. The Yasin-M features a massive spherical bow sonar array occupying much of the vessel's forward section. The array is so large that engineers were forced to relocate the submarine's torpedo tubes farther toward the rear of the vessel, an unusual design decision that highlights the importance Russian planners placed on situational awareness. Military analysts believe this enormous sonar complex provides exceptionally long detection ranges, allowing the submarine to identify and track enemy vessels while remaining concealed. Additional flank-mounted sensors and towed sonar arrays further enhance the submarine's ability to gather intelligence and monitor threats across vast maritime areas. The submarine's origins can be traced back to Soviet efforts to counter American carrier strike groups during the Cold War. Russian naval planners wanted a vessel capable of locating, tracking, and destroying powerful U.S. Navy formations operating far from Russian shores. That mission requirement helped shape virtually every aspect of the Yasin design. Unlike previous Soviet submarines that often specialized in a single mission set, the Yasin was conceived as a hybrid platform capable of performing multiple strategic roles simultaneously. The vessel combines the hunter-killer functions associated with the Akula-class submarine with the long-range cruise missile strike capabilities traditionally performed by the much larger Oscar II class. As a result, a single Yasen submarine can conduct anti-submarine warfare, anti-ship warfare, intelligence gathering, strategic reconnaissance, and deep strike attacks against land-based targets. Few submarines anywhere in the world were designed from the outset to perform such a broad range of missions. Another major contributor to the submarine's effectiveness is its high degree of automation. Despite its enormous size, the vessel requires a crew of only 64 personnel. That figure is particularly striking because many smaller Western submarines often require crews exceeding 100 sailors. Advanced automation systems handle engineering operations, weapons management, and ship control functions, allowing the submarine to operate efficiently with a much smaller complement. Yet perhaps the most significant development in recent years has been the integration of Russia's 3M-22 Zircon hypersonic cruise missile. Beginning in 2025, Yasen-M submarines gained the ability to deploy this next-generation weapon, dramatically expanding their strike capabilities against both naval and land-based targets. The Zircon missile is considered one of the most challenging weapons currently facing modern air defense systems. Traveling at speeds approaching Mach 9, the missile dramatically reduces the amount of time available for detection, tracking, decision-making, and interception. Its combination of extreme speed, maneuverability, and limited warning time creates significant challenges for defending forces attempting to stop an incoming attack. Military experts note that the missile is capable of executing evasive maneuvers during the final stages of flight, further complicating interception efforts. The addition of Zircon transforms the Yasen-M from an already formidable attack submarine into an even more dangerous strategic asset, capable of threatening aircraft carriers, major warships, command centers, and high-value military targets from far greater standoff distances. For Russia, the integration of hypersonic weapons